Thank you for chairperson. Hello everyone. Thank you for attending our talk. Today I'd like to talk about new findings of Goby-shrimp symbiosis. Goby-shrimp symbiosis is a common phenomenon in coral reefs. In this relationship, host shrimp provide a refuge and breeding site to their partners, and in turn, gobies want the host shrimp of approaching predators. Such goby-shrimp symbiosis is described in many textbooks, but their actual relationship remains unknown. Recently, we proposed a new hypothesis that is mutual food provisioning hypothesis. Here you can see the movie in the field. This is a goby, this is a group, and this is a burrow entrance. Okay, start. So this is a signal tail wave by goby to let the shrimp out the burrow. And then the shrimp came out from the burrow. The shrimp started digging, continue digging, and digging. And finally, the goby foraged on benthos on the bottom soon after digging by shrimp. This is a summary of the hypothesis. First, the goby sends the host shrimp a signal tail wave to let the shrimp out the burrow. Then the shrimp help raising in gobies by excavating sand sediment outside their burrows. And in turn, the goby provides its droppings as vital food for the host shrimp. Our field studies and aquarium experiments provide strong evidence for the hypothesis. However, to verify the hypothesis, experiments to manipulate food intake are required. So, to verify mutual food provisioning hypothesis, we conducted field experiments by artificially feeding shrimp and or gobies. Field studies were conducted from June to October in 2019 and 2020 on the coral reef at Morode, Japan. These are the study species, the goby and the snapping shrimp. Behaviors of goby shrimp pairs were recorded using video cameras and also using scuba. This is the flow of the experiment. This is very important. Behaviors of gobies and shrimp were recorded for 45 minutes before and after the treatment. The treatment was as follows. In the experiment of feeding both gobies and shrimp, we fed the goby with live polychaeta worms and fed the shrimp with artificial feed made from feces of gobies, like this. In the experiment of feeding only gobies, we fed the goby with live polychaeta worms but pretended to feed shrimp. Similarly, in the experiments of feeding only shrimp, we pretend to feed goby, but fed the shrimp with feces of gobies. As a control experiment, we pretended to feed both gobies and shrimp. Finally, we collected data of 10 pairs for each treatment and analyzed the behavioral data using video recordings. These are predictions when we feed shrimp. If our hypothesis is correct, digging frequency by shrimp outside the burrow and time spent outside the burrow by shrimp should decrease. And consequently, the frequency of foraging of benthos by the goby should decrease. But signal tail wave frequency and time spent outside the burrow by gobies should not change because the gobies are hungry. In contrast, when we feed gobies, the frequency of foraging on benthos by the goby should decrease because the goby was stuffed. And consequently, signal tail wave frequency and time spent outside the burrow by gobies should also decrease. And finally, digging frequency by shrimp outside the burrow and time spent outside the burrow by shrimp should also decrease. Here you can see the results of signal tail wave frequency by gobies to let shrimp out of the burrow. X-axis shows the before and after the treatment. So, as predicted, after we fed goby, the goby decreased sending signal to shrimp. But after we fed only shrimp, goby continued sending signals because the goby was hungry. These are the results of digging by shrimp and foraging frequency by gobies. And as predicted, after we fed goby and shrimp, shrimp stopped digging outside the burrow. In addition, after we fed gobies, the goby stopped foraging on benthos because the goby was stuffed. And even after we fed only shrimp, feeding frequency by the goby decreased. This is probably because shrimp did not have foraging in gobies by excavating sand sediments. These are the final results. Here you can see time spent outside the burrow by shrimp and gobies. After we fed gobies or shrimp, shrimp stayed in the burrow as predicted. Similarly, after we fed gobies, gobies stayed in the burrow. But after we fed only shrimp, goby stayed outside the burrow, probably because the goby was hungry. In summary, we found that behaviors of gobies and shrimp dramatically changed by artificial feeding experiment in the field. Thus, our results demonstrate the first evidence for mutual food provisioning hypothesis. We also found that gobies stopped warning the host shrimp of approaching predators. Shrimp also stopped helping foraging in gobies because they are stuffed. So, we think that in the goby-shrimp relationship, mutualistic may be selfish, but not altruistic. Thank you for your attention.